Hi, and welcome to the Learning Zone. I'm Mr. B. After watching this lesson, you will be able to identify, to name, and to state the properties of Arrhenius acids and bases. Let's begin the lesson with Arrhenius acids. An Arrhenius acid is a substance that, when added to water, increases the concentration of hydrogen ion, or H+. The chemical formula for an Arrhenius acid is written with the acidic hydrogen first, while the general formula is written as HA, where H represents the hydrogen ion and A represents an anion. Remember, anions are ions of nonmetallic elements or polyatomic ions. Consider the following example where the compound hydrogen chloride is added to water. When hydrogen chloride is added to water, the proton associated with the hydrogen chloride molecule will dissociate. The proton is then attracted to a lone pair of electrons around the water molecule. This leads to the formation of what is called a coordinate covalent bond and the production of H3O plus, hydronium ion. Some of the general properties associated with acids are listed as follows, where acids will conduct electricity and are therefore called electrolytes. Acids will have a sour taste. Acids will react with bases to form a salt or an ionic compound and water. Acid will turn blue litmus paper red, and acids will react with metals to produce a salt, an ionic compound, and hydrogen gas. The simplest type of Arrhenius acids are called binary acids. Binary acids contain one or more hydrogen ions and an ion of a halogen or a group 16 element. All binary acids are named the same way. The prefix will always be hydro, followed by the root of the anion found in the acid. The suffix, the ending, will always be IC, and the word acid will be the second word in the name. For example, HCl is called hydrochloric acid. Other examples of binary acids include the following: H2S, hydrosulfuric acid; H2SE, hydroselenic acid; HF, hydrofluoric acid; HCl, hydrochloric acid; HBr, hydrobromic acid; and HI, hydroiodic acid. Astatine, AT will also form an acid. However, HAT, hydroastatinic acid, readily breaks down to form hydrogen gas. And the fact that astatine is radioactive limits its usefulness. The following binary acids are listed in order of increasing strength, where the two diprotic acids formed from group 16 elements will be the weakest. H2S, H2SE, HF, HCl, HBr, and HI, where HI, hydroiodic acid, will be the strongest acid on the list. Now for Arrhenius bases. An Arrhenius base is a substance that increases the concentration of hydroxide ion when added to water. The general formula for an Arrhenius base is MOH, where M represents the metallic ion found in the molecule and OH represents the hydroxide ion found in the molecule. In terms of properties, bases will conduct electricity, as does acids. So bases are also known as electrolytes. Bases will taste bitter, and bases will react with acids to form a salt and water. Bases turn red litmus paper blue, and bases will turn the indicator phenolphthalein pink. Bases will also have a slippery feel or are slippery to the touch. All Arrhenius bases are named the same way, where the bases will always have hydroxide ion and some metallic cation. For example, if a base contains sodium Na plus cation and the anion OH, the chemical formula will be NaOH, and the name will be sodium hydroxide. If the base contains the aluminum cation, Al3 plus or plus 3, and hydroxide ion, the chemical formula will be AlOH3, and the name of the base will be aluminum hydroxide. Bases formed from group 1 ions will be the strongest bases because these bases will ionize completely when added to water. From group 1, LiOH, NaOH, KOH, RbOH, CSOH, and FrOH are listed in order of increasing strength, where cesium hydroxide, CSOH, is powerful enough to corrode glass, and francium hydroxide, FrOH, is the most powerful base. However, because francium is radioactive, undergoing beta decay, limits the usefulness of francium hydroxide. Bases containing group 2 cations will be weaker bases because these bases are less soluble in water. From group 2, calcium hydroxide, strontium hydroxide, and barium hydroxide will be formed. And of course, these bases are listed in order of increasing strength. When ammonia is added to water, a proton from the water molecule will be attracted to the lone pair of electrons around the ammonia molecule. This leads to the formation of ammonium ion, NH4+, and the production of hydroxide ion. Therefore, by definition, ammonia will also act as an Arrhenius base. This concludes my lesson on how to identify, name, and state the properties of Arrhenius acids and bases. Hopefully, this video has been helpful. Thanks for watching.